This video is about edge detection, noise, and the Canny edge detector. Edge detection is the approach used most frequently for segmenting images based on abrupt changes in intensity. There are three fundamental steps performed in edge detection: image smoothing for noise reduction, detection of edge points, and edge localization. To perform edge detection, you have to perform some image smoothing for noise reduction. The next step, if using a search-based method, is to use a filter that calculates the gradient of every pixel in the image. The gradients are then used to estimate the edge strength and direction. This can be done using a Sobel filter. An edge point is then a peak in the magnitude of the gradient of the smoothed image in the direction of the gradient. Edge detectors use the first derivatives to find edges. And derivatives are very sensitive to noise, therefore you should do some image smoothing before applying the Sobel filter. This is the Canny edge detector step by step. First, form a smoothed image by convolving the input image with a Gaussian filter. Next, compute the gradient magnitude and direction of each pixel in the smoothed image. Then use non-maxima suppression to thin out the ridges. And finally, connect and link edges by using double thresholding and connectivity analysis. Here you can see an example of a smoothed image. To the left is the original image and to the right is the smoothed one. The next step is then to compute the gradient magnitude and direction of each pixel in the smoothed image. Before computing the gradient magnitude and direction, you have to convert the image to grayscale. Then it's the non-maxima suppression. If the current pixel has a magnitude less than at least one of its neighbors, we perform a suppression. This means setting the magnitude value to 0. Else, we keep the current magnitude value. Here is also an illustration of the concept of the non-maxima suppression. The final operation is double thresholding and connectivity analysis to reduce false edge pixels. We choose a lower threshold TL and a higher threshold TH. Setting the threshold right is important. If you choose TL too low, you will await too many details, and if you choose TH too high, you will lose important details or edges. Canny suggests that the ratio of the high to low threshold should be 2 or 3 to 1. Next, we create two new pictures: G&H with threshold TH and GNL with threshold TL. Afterwards, we subtract the image with TH as threshold with the image with the lower threshold. This is due to avoid having duplicate edge pixels. All the pixels in G&H are assumed to be valid edge pixels. The problem now is that G&H probably have gaps between the pixels because of the high threshold. This problem is solved by going through the pixels in G&H and use, for example, 8 connectivity, and mark all the pixels in GNL that are connected as valid. In the end, set all the pixels in GNL that were not marked as valid to 0. Here's an example of thresholding: TL to the left and TH to the right.